All right, so Peter, if you're listening to the recording, we're just, as I said last week, we're just going to go through a lot of questions from Unit 4. And the goal is you guys have to go back and redo it yourself. You guys will have like an entire week next week of no schoolwork. So you better do this revision for Unit 4. Your exam's coming up very soon. We have done all content, so it's entirely up to you guys now. So let's just go through the questions. Now, if you guys were to revisit these questions later, in the notes, the idea is that you should try to do it without looking at my answer. So remember that memory graph thing, like the one where like it goes up and then you forget a little bit, and then go up and you forget a little bit. You need to allow that forgetting. This curve is originally called the forgetting curve because they care more about the forgetting part. Because after that, if it goes up again, then it would decrease in terms of like the forgetfulness of the content. So that's why right after today's lesson, Steven, you need to go back tonight, redo the questions.
Yeah.
Right, that's the very first pick here, right? When you finish the lesson, you'll be at that point, right? That's a lesson end, right? And then when you go back home, you start forgetting. And then tonight, when you do it again, that's when it bumps up. Yeah. So if it bumps up straight away, hopefully it will take longer to forget. And then you'll do more revision next week, and then it will just keep on staying at the high level. Yeah. Okay, so that's the goal for the forgetting curve. Okay. Let's go through some of the simple familiar. Let's see. I'll pick only the one that's a little bit trickier in terms of simple familiar. All right. So let's see. So out of these ones, I'll just go straight to question B. Okay, and this is chapter 19. Peter, if you're listening, I'll send this to you on Discord. Chapter 19. Tech-free. This is tech-free. We'll focus on tech-free today. Okay, second derivative. First one, easy. Not going to do that. Second one, the answer is -1/4 e power -x on 4. Alright, any questions, Steven? No? Easy stuff. This one, what's the rule here?
Product rule.
Product rule, very good. So there are two factors, x and e to the power -5x. Just use the product rule, you'll be fine. And then this one is just the same as that one, but just two terms. You derive each term separately. Yeah. Okay, not too bad. All this stuff is easy. Okay, actually maybe I'll just use this one. All right, so let's say for question 2, right? Find the velocity and acceleration. How do we find velocity and acceleration?
Just derive.
Just derive, right? So v would be 6t squared minus 24, and acceleration is 12t. That's it.
Yeah.
Okay. All right. Next would be, okay, let's go through question 3. Let fx equals to that one there. Find f dash. Now, what is f dash x here? This is the product rule. If you guys can, try to do it. So this is u and v, right? Try to do it straight away. So u dash is 1. You can write 1 when you're applying the product rule, so it's a bit easier to see. 1 times v dash. Now, the v is a little bit more complicated. Just remember, if it's e to the power something, it will always remain the same, right? And then you multiply that by the derivative of the power. So that will be 4x minus 4. Okay? Write it in that form first, and then plus u dash v, and then actually this one should be the same first. U dash v, and then plus u, which is x, and then v dash. So then that's the one that we have to derive. Okay, so this is the v dash one. So 4x minus 4. Okay, and when you see something like that, you can always take out the common factor, 2x squared minus 4x, and then simplify it. Okay, if I were to take that out, that'll be e to the power 2x squared minus 4x, and then in the brackets will be 1 plus, expand this out of brackets, will be 4x squared minus 4x. Okay, so that would be the f dash of x. And now show that this one is more than 0, more than or equals to 0 for all x. So we need to say that regardless of what x is, this will always be positive. Right? This one's a little bit tricky, but if you were to factorize this expression here, try at home, but what you will get is 2x minus 1, everything squared. Okay, if you factorize it, you get 2x minus 1, everything squared. So remember, this is a non-monic, so after the ACB table, you will need to split the middle term up. So that one, you need to rearrange it as 4x squared minus 4x plus 1. And then ACB table will be, AC will be 4, and then B will be -4. Right? So that will be add up to negative 4. So negative 2 and negative 2. But you gotta split the middle term up and then rearrange it. You will get 2x minus 1 everything squared. And this one would be that. So why is this always positive? Why is this always positive? What do you think, Stephen?
Oh, because if it's like it'll always be positive when in the bracket times by like whatever. I don't know. It's just a weird question.
This is a factor, right? If both factors are positive, then the whole thing will always be positive. Now, e raised to anything is always positive, right? And then 2x minus 1, regardless of what x is, when you square that, it's also positive. And because each of these factors are positive, always positive, the f dash x is always positive for all x. Yeah? And then show that the only stationary point on the graph is the stationary point of inflection. So when you set this equals to 0, okay, stationary point of inflection. So when you set this equals to 0, you would get, the first one is strictly positive, the second one could be equals to 0. So you get 2x minus 1 equals to 0, and then therefore x would be 1 over 2. Alright? Now, you can technically, you can find the second derivative at this point. You can find it. It's not too hard. You can find the second derivative and then sub this value in to see if the second derivative of this. So show that this one must be equal to 0. Right? Because the stationary point of inflection will have the second derivative equals to 0 as well as the first derivative equals to 0. Okay? So that's what you can do. So derive it again, sub the value in. Otherwise, you can try to calculate, but actually wouldn't recommend that. Oh wait, hang on, let's see. It's always positive. Oh yeah, no, you actually don't need that. Okay, so at this point, so note that at this point is a, at this point x equals to 1/2 is a stationary point. So what we're saying is this, it must be stationary, right? And what we just proved is that the first derivative is always positive, which means before that, the gradient must be positive. And after that, the gradient is also positive.
Yeah.
Right? Because we just proved in question B that the first derivative, aka the gradient function, is always positive. Positive or equals to 0. Right? So at the stationary point, that's the only stationary point. And before that, the gradient must be positive. After that, the gradient must be positive. Therefore, that must be a stationary point of inflection. Okay? So yeah, so actually maybe I'll do this complex familiar in the notes, so it's a bit easier to see. But yeah, so that's question 3. Question 4, how do we find the values of x for which the graph is concave up? What does that mean? What does that mean? Find the values of x for which the graph is concave up. Concave up means what?
Yeah, like that?
Yeah, and based on first and second derivative.
Oh, I can't remember. There's like 3 things for it.
The second derivative is concavity.
Second derivative.
Okay, so the second derivative must be more than 0 for it to concave up.
Yeah.
Yeah? So for it to concave up, the second derivative equals, it must be more than 0. So actually I'll walk through this one as an example. This is one of the more difficult simple familiar. Hi, it's still simple familiar because it just relies on the only concept that concavity is second derivative. So concave up means second derivative is more than 0. So then we already derive that twice. F dash would be 3x squared minus 6x. And then the second derivative would be 6x minus 6. Okay. Now we can, there are 2 ways of solving for when the second derivative is more than 0. First is you can sketch it. Alright. If we were to sketch it, this is a linear equation, right? And then when you sub x equals to 0, y is negative 6. And then when x is 1, y is 0. So it will be like this. 6x minus 6. The gradient is 6. Okay, so for which part of it is the graph concave up? Now note that this is the second derivative. Yeah, this is f double dash of x, right? That's a graph of the second derivative. And so we want the second derivative is more than 0, which means we are talking about this section here. So therefore, the answer is x must be more than 1. Okay, note that this is graph of the second derivative. It means that in the main graph, right, in the main graph, when x is more than 1, it will have to be concave up somehow, right? We don't know what happens before 1, but we know that after 1, it has to concave up, right? So this is the graph, the main graph fx, okay? And when you translate the concavity, it is when the second derivative is positive.
Oh, yeah.
Okay, or if you want to solve it, there is another way to solve it. So this one, the second way would be, say, second derivative must be more than 0 for concave up, and then you sub it in 6x minus 6 more than 0. Solve this inequality. Move the negative 6 over 6x is more than positive 6, and then divide both sides by 6, then x is more than 1. Okay, note that when you're solving for inequalities, if you're dividing by a negative, you flip the sign. Okay, remember that. So for example, let's say in quick recap on inequalities. So if you have 6x must be more than 6, then yes, x is more than 1. But if you have negative of 6x is more than 6, then x must be less than, right? When you divide it by negative 6, okay, the answer would be flipped around. X is less than negative 1. Because let's test it, right? When x, so for example, you see when there's negative, it flips your expectation around a little bit. So when x is less than negative 1, which is negative 2, right? Then negative 6 times x would be negative 6 times negative 2, which is 12. And then this one is more than 6. Okay? Yeah, so that's why when you're dividing by a negative number, you have to flip the sign around for inequalities. All right. Next question. Question 5. Find the coordinates of the, so that's the equation there. And then we're given a domain. Find the coordinates of the points of inflection on the graph. Well, this one is actually fairly simple. You just need to, hang on, let me see. Should I work through this one? 4 times 2 sine. Okay, yeah, I'll work through this one. Let's see how many questions we can cover. All right. Okay, how do we solve for coordinates of points of inflection? Steven?
I can't remember.
Points of inflection links to the second derivative. And what about it?
I can't remember.
There are only 2 special points, okay? Stationary points, and the new one in Unit 4 is the understand about the point of inflection. Okay, stationary point is when the first derivative is equal to 0, right? Or the gradient is 0 at that point. The point of inflection is also the change in concavity. Okay, and this is when the second derivative is equals to 0.
Yeah.
Yeah, so point of inflection is like a point where, let's say this is the gradient. It was concave down before, it has to concave up after. So that's a point of inflection, right? And the stationary point of inflection would be the gradient is horizontal at that point, and if it's concaving up before, it has to concave down after. So this is the stationary point of inflection, and this is a normal point of inflection.
Yeah.
Okay, so that's a quick recap. So coordinates of the points of inflection. All right, moving on. So yeah, so coordinates of the point of inflection, we'll derive that first. So that would be 4, and then sine is cos. So minus 2 cos. The 2 comes from deriving 2x, for anyone who's wondering. And then f double dash of x would be 4 is 0 and negative. So cos is negative sine, so that will be 4 sine of 2x. All right, points of inflection. Therefore, the second derivative must be equals to 0 at that point. So set 0 equals to 4 sine of 2x. Okay, and then divide both sides by 4, and we get up to this point here. Now, how do we solve for this? The answer is we're solving for 2x. Okay, and if we're solving for 2x, we need a domain for 2x. This domain at the moment is for x. So when you're solving for trigonometry equation, always pay attention to the domain to know how many answers you will get. Because essentially what they're saying is this, this is the function. How many times does it cross through the x-axis? It will cross through multiple times for a sine function. right? And that's why you need to know what is the domain, so to know how many answers there are. Now this is x. If you want to get 2x, you times that by 2 on everything. So 0 times 2 is 0, x times 2 is 2x, and 2 pi times 2 is 4 pi. How many answers are there, Steven?
Sine 2x.
How many answers are there?
4?
4 answers, correct. 4 answers because that's 2 cycles, right? Every 2 pi is a cycle, so 4 pi would be 2 cycles.
Yeah.
Alright, 2 cycles. Now sine equals to 0. So which point gives me sine equals to 0? This is the sine axis. Right, which point gives me sine equals to 0? Remember, the y coordinate is the sine value. Right, so that will be this point and this point.
Yeah.
Does it make sense, Steven?
Yeah.
Are you sure?
Yeah.
You need to also work this out by yourself, yeah?
Yeah.
Okay. So these 2 points sine is equal to 0. What's the first angle here?
0.
0. What's this angle here?
Pi.
Pi. That's right. So 0 and pi. So the answers for 2x, the first two will be 0 and pi. And when you add to it, that will be 2 pi and 3 pi. Is that all? Is there anything that we're missing? This one has this is a special case where the first point corresponds to 2 angles. Right? 0 or 2 pi or 4 pi. And the other one is pi or 3 pi. So in fact, when sine equals to 0, okay, when sine equals to 0, there are always more than the number of answers that you're expecting. So if you think 4, there will be 5. 0 is one of them. And then the final part of the domain, 4 pi, is also one of the answers. Okay, so be very careful. When sine equals to 0, it will have one more answer. So for example, right, let's say given, so 0 less than equals x less than equals 2 pi. Okay, find x where sine x equals to 0. Alright, sine x equals to 0 means that you need circle and then the 2 points are the left point and the right point. So note that you start the first angle that satisfied is 0. And then add pi is this one here. Now the last angle is 2 pi. Right? Because 2 pi is still within the domain. Because the two of the solutions actually comes from the domain itself, 0 and 2 pi. And then the other one is the one that's on the other side. That also gives sine equals to 0. So this one actually gives 3 solutions. X equals to 0, pi, or 2 pi. Okay, so this is the special case when sine of an angle equals to 0. Given a normal domain, there will be 3 answers instead of 2.
Yeah.
Okay, because one point represents 2 answers, 0 and 2 pi. This point here.
Yeah.
So that is why there will be 5 answers here, and then in order to get x, you need to divide both sides by 2. So 0 by 2 is 0, pi on 2, and then pi, and then 3 pi on 2, and then 2 pi. Okay? So see, now that we have got up to this point, that will be the final answer. And does it satisfy the main initial domain? Yes, it does. It starts from 0, ends at 2 pi. Okay? So when you're solving trigonometry equations, make sure to always change the domain up. Right? This is considered simple familiar for Unit 4 because you should have done this type of question many times before. Okay, next is question 6. Polynomial function f has derivative with that rule there. Solve this equals to 0, and given that the second derivative equals to that, determine the nature of the stationary point corresponding to the x values and find the x values at which there is a point of inflection. This question is really not hard. They give you, so solve f dash equals to 0, I can tell x would be, based on this, each of the factor would be 0, right? So that would be 1, -1, and +3. Okay? And they give you the second derivative. Now this is the part that you guys, if you guys know a certain technique, it will make things a little bit easier. So Peter, if you're listening to the recording, this question will use the concept that you asked me earlier, where whether we need to calculate the actual value of f double dash of the second derivative, and the answer is no. So question A, solve f dash equals to 0. So x would be, you can quickly see that 1, -1 or 3. And then to calculate the second derivative, they already gave us the version of the second derivative. So note that they gave us the factorized version because normally it's easier to use. So f double dash of 1, right, would be 4 and then sub 1 in here, I get 0, which means this will be instantly 0. Right? Once you get one of the factors to be 0, the rest is just 0. And then the second derivative at -1 would be, okay, so the first is 4 and then -1 is -2. And then this one would be -1 squared is 1 and then -2 times -1 is +2 minus 1. So that would be, so this one, you can actually analyze it without working through the final answer. This is more than 0. This is less than 0 and 4 is more than 0. Therefore, the whole thing will be less than 0. Alright, does it make sense, Steven?
Yeah.
Yeah, because negative times positive is negative, right? And 4 is positive. So they're all positive except for one of them. So that's why the answer will be negative. You don't even need to work out what that answer is. Second derivative at 3 would be 4 times 3 minus 1 is 2. And that would be 9 minus 6 minus 1. So that's positive, positive. Right, so that's positive. 9 minus 6 minus 1 is 2. That's also positive. So this whole thing will be more than 0. So from the first one, I can conclude that nature stationary point. So stationary point at x equals 1 is stationary point of inflection because the second derivative equals to 0. This one, the stationary point at x negative equals to -1 is, now how do we tell? Second derivative less than 0. So this one means concave down. Right? Yeah? Concave down means what? Means it should somewhat look like that. Therefore, it is a local max.
Yeah.
Okay? Then the next one, more than 0 means concave up. Right? Therefore, the stationary point at x equals 3 is local minimum.
Yeah.
Okay? And then question C, find the x values at which there is a point of inflection. So C, point of inflection, is the same thing as second derivative equals to 0. That's why they gave us the factorized version. So we can use that straight away. 4 times x minus 1, x squared minus 2x minus 1 equals to 0. Okay, let's solve that. So no factor law, x equals 1 or this thing. Now, sure, you guys can solve quadratics, but before you solve quadratics, remember one thing. Check determinant. Okay, so this technique came from Unit 1. Most teacher may or may not mention this, but I think this is an important exam technique. You check the determinant. What's the determinant formula, Steven?
Isn't it like triangle equals?
It's delta. Pronounced delta, yes. Delta equals?
Or minus AC something? I don't know.
B squared minus...
minus 4AC.
4AC, yes. Okay, so b squared minus 4ac is the determinant. So this one, b squared, so therefore I'll write determinant equals to -2 squared, that will be 4. Actually, I'll write it here. -2 squared minus 4 times 1 times -1. So that'll be 4, and then plus 4 times 1 times -1 is 4. So that will be 8. Means that there are 2 solutions. Okay? And when you see the determinant as not a perfect number, like not a perfect square, you know the answer is in square roots. Okay, let's see, find the x values, right? Because the x answer will always be minus b. The formula is minus b plus minus square root determinant over 2a. So you see, once you calculate the determinant, it will be a lot easier to write out the answer. So this one would be minus b, which is minus -2, so that's 2. Plus minus square root 8. You see why the answer would not be a rational answer, right? It will be an irrational number because 8 is not a perfect square and we have to square root that. Over 2 times 8, which is 2. So then this one, they will require you to simplify that. So 2 plus minus 2 root 2 over 2, divide everything by 2, top and bottom, that will be 1 plus minus square root 2. Okay, so therefore the point of inflection at these x values, x equals 1 or 1 plus square root 2 or 1 minus square root 2. 3 points of inflection. And they only ask us for the x value, well, not the y value, so we don't need to find the y value. So we need to sub it back into the original. Okay. Alright, so that's question 6, simple familiar. Let's see. Trigonometry, discrete random variables. Okay, we'll get to these soon enough. Sketch the graph. Now, this one is very similar to what we did before. So I'm not going to go through this one. Sketch the graph. I'll just list out the steps. So stationary point, set first derivative equals to 0, and then you find the x, right? Find x, and then you sub into the main equation to find y, right? For y coordinate. We did this on like a week or 2 weeks ago, so I'm not going to go through the exact same question again. Sub into fx or the y coordinates, and then sub into, right? So actually, you gotta find the second derivative. Find second derivative, right? And then you sub the x values into from the stationary point into the second derivative to find the nature. Actually, you know what? Let me put the steps into the notes. Okay. Okay. So actually the first step is always to find f dash of x by deriving it once, and the second derivative, deriving it twice. So after this, I'm going to assume that you guys would have gotten both the first and the second derivative. And then there are two main steps. So one is find the stationary points, and then the other one is find the point of inflection. Now, stationary point, first step, set first derivative equals to 0, and then find x. And then you need to find the y coordinates, right, at each of those, and then you need to find the nature of the stationary point. Is it local max, local min, or stationary point of inflection? Okay, so that's the purpose. All right, so how do we find y coordinate? Sub x into the original equation, fx. And then how do we find the nature? We sub x into the second derivative. Very, very standard steps, right? So once you've got the nature, then that's it. That's all of the stationary points. Then you've got to find the point of inflection. Okay, so point of inflection, first step, set second derivative equals to 0. Okay, and then find x. Now we need the actual points, so we need to find the y coordinates again, right? Find y coordinates by using sub x into the original. Okay, very similar. So when you have the point of inflection, you don't need to find the nature of it. So that's it for point of inflection. And then step 4, once you've got all of these, step 4, sketch. Okay, so to sketch, first you put in the points, put in the stationary points and point of inflection. Okay, and then you join them. That's it. So when you're joining them, note that if you can find the x and y intercepts if possible. Okay, so these are all the steps to sketch a polynomial. I'm not going to go through the question, right? Because follow these steps. If any of you have any trouble, you can ask that on Discord, and then I'll go through the actual answer. But any question for this set, Steven? No? Okay, we'll move on first. Trigonometry using sine cosine rule, find cosine of the smallest angle of this triangle. So I'll skip the easy stuff. This one is just cosine rule, right? Because when you get 3 sides, cosine rule is the only one that will go through all three sides. What's the cosine rule, Steven?
C squared equals A plus B minus
A squared
plus B squared minus 2AB cos C.
Yeah, just use that. Alright. Then question 9. Triangle ABC has area 20 centimeters squared. The length of AB is 10. Length of AC is 12. Find angle BAC. Find sine of angle BAC. What's the area rule?
Half of BC sine A.
Yeah, half BC sine A. Yes. Now this just means that A is the included angle. Yeah, it's not the opposite. It's the included angle. So for example, in this case, we have A, B, and C. So we know AB is 10, AC is 12. So note that I'm drawing this, so you guys should draw that when you're doing the question as well. Find sine of angle BAC. Oh, that's literally just the included angle, right? So then you got the area is half times the two other sides. So half times 10 times 12 times sine of angle BAC equals to the area 20. Basically just algebra, work it out. They don't even ask you for the angle, right? Because it's tech free. So they ask for what that value is. Easy. Next is the three side lengths of a triangle are root 2, 2, and 1 plus root 3. Find cosine of the largest angle. Cosine of the largest angle. So if you were to, now the trick is, if you were to draw it out, you need to know where is the largest angle. Actually, maybe I'll go through this one. This one you need to have a little intuition using the sine rule as well as the cosine rule. Otherwise, it will take you a long time to figure out this question. If you do know the relationship, it will be a lot easier. So, estimate this value. Steven, estimate this value.
Like, I don't know, 1.5?
Okay, let's say 1.5.
Because that's 3. Maybe like 1.
No, it's not 3. You're supposed to multiply that together to get, right? Because we were saying that it will be a number where when you square that, it will be approximately 2.
Yeah.
So you have to times it by yourself, not times it by 2. So 1.5 is okay because if you actually work out 1.5 times 1.5, I think it's about 1.7, no, about 2.2. Yeah, so that'd be 225, 2.25, so roughly less than that, right? So let's say 1.4, okay?
Yeah.
Good enough, right? The reason why it's good enough is because you only need to know roughly what the values are. What's 1 plus root 3? What is square root of 3?
1.8, 1.9.
Yeah, okay, let's say this is 1.8, 1.9 because 2 is 4, right? So let's say that's 1.8. 1 plus 1.8 is roughly 2.8. So do you see that this number is the smallest and this is the middle one and this is the biggest number?
You can figure out like the size.
Yeah, to figure out which angle is the largest one. So for example, if I were to draw this, A, B, and C, right? I put root 2 here, and 1 plus square root 3 here. Which angle is the largest?
BC? Or
the angle. Angle A, angle B, or angle C?
Oh, I don't know. Maybe angle A. Angle A?
Yes, it's the angle A. The angle facing the longer side will also be the largest angle. Okay? The reason why you need this is because you can actually work out cosine of the largest angle straight away in one step. Otherwise, if you don't, you need to do all of them and give your answer in the largest angle. So you have to make a reasoning since BC is the largest side, right? Angle A is the largest angle. Largest angle. Why? Why is that the case? Now, note that you have A, like for example, A over sine angle A is equals to B over sine angle B, right? So let's just say the ratio equals to 1/2. If B is, let's say 2, then sine B must be 4, right? In order to get 1/2, right? And then if A is like 3, then sine A must be 6, right? In order to get 1/2, because 3 over 6 is 1/2. And that's why you see if A is larger than B, then B is 2. If A is larger than B, then sine A will also be larger than sine B. And in the world of like positive angles, the larger the sine value, the greater the angle will be. If there are no obtuse angles.
Yeah. Okay.
Okay. So yeah, there are no obtuse angle. Okay. And then so angle A is the largest angle, which means that you can go C squared. So C is the side opposite of that, so that would be this one here, or A, you can use A squared one. But basically, if you look at this angle here, right, this is the included angle, so the two sides next to it will be this one and this one. Okay, then the other side will be 1 plus square root 3 everything squared is equals to root 2 squared plus 2 squared minus 2 times root 2 times 2 times cos of the angle A.
Yeah.
Okay, then this one is when you use that expansion. So be 1 squared plus 2 times 1 times root 3 plus root 3 squared. Remember that? The A plus B everything squared.
Yeah.
Yeah. And then this one will be 2 plus 4 minus 4 root 2 cos A. So rearranging it, move the 4 root 2 cos A over to this side, and then move this whole thing to the other side. Well, 1 plus 3 is just 4. So yeah, I'll move that one over here. So let's just keep it simple and work out one at a time. So 2 plus 4 minus 1 minus 2 root 3 minus 3. I'm just doing one at a time. Then I divide both sides by 4 root 2 and simplifying the top. 2 plus 4 minus 1 minus 3 would just be 2 minus 2 square root 3 over 4 square root 2. So cos A equals that. Divide each term by 2, both top and bottom. It will be 1 minus root 3 over 2 root 2. Rationalizing the denominator times the top and bottom by square root 2. Right? So the top would be root 2 minus root 6 over 4. So I'm pretty sure that's the final answer.
Yeah.
Okay, so that's the cosine of the largest angle in this question here. All right, so that was a tricky one. Right, it's not easy, but it's not overly difficult either. That's why it's just still considered a simple familiar. And then question 11. Consider triangle ABC with AB equals 6, AC is 4, and angle BAC is 60 degrees. Find the length BC. And then we need to give the answer in third form. So find the length BC. We've got two angles, right, and an angle. We'll see what kind of angle it is. If it's the included angle, then it's the cosine rule, right? If it's non-included angle, then it can be the sine rule. So let's draw it out. A, B, and C. AB is 6, AC is 4. So maybe we'll swap these one. AB is here, AC is here. So AB is 6, AC is 4, and BAC. So look at the middle one. Okay, when you look at an angle, you look at the middle one. So the anchor is at A, which means this is the angle. Aha, this is the included angle. So it has to be the cosine rule, right, to find the length BC. So yeah, use cosine rule, find the length BC. That means you need to find cos of the angle BAC. What's cos 60?
That's not on there. Oh wait, no it is. Wait, is it? No, it's 30, 45,
And
90, isn't it?
you can always do multiples of 90, but there is another angle that's not 90, not multiple of 90, you can work through.
I have to do it. I can't remember the triangles.
The two triangles are equilateral and isosceles.
Yeah, I remember those, but I can't remember them in my head. Like that one's root 3, 2, and 1.
If this angle is 30 degrees, then the other one is 60 degrees.
Yeah, cos of adjacent one. So 1 over root 3, so
Over hypotenuse.
1 over 2, 1 over 2. Oh.
Can't make this mistake now.
I know, right? I can't do it in my head. I have to write it out.
You can't do it in your head because you haven't done it enough times.
Yeah, I can draw the triangle. I just can't like.
Okay. As long as you get the right triangle, I just drew the triangle for you. Still got it wrong. Gotta learn to recognize the hypotenuse. Remember, it's always the longer side. It's a side that is not attached. That's why I draw the right angle here. See, The hypotenuse is the side that the right angle looks at.
Yeah.
All right. If I draw any triangle, right, it doesn't matter which direction I draw the triangle. If I draw the right angle here, then this is the hypotenuse.
Yeah, I don't.
It's the one that doesn't
It's a
touch the
longer
right
side.
angle.
It's a longer side.
There's a longer side. So any side that touches the right angle is not the hypotenuse.
Yeah.
Okay, you gotta tell yourself that. Get used to this.
Yeah.
And then find area rule. Not too bad. Find sine 160. Okay, and then you're gonna find in the third form. Okay, question 12. Consider this triangle here. We've got AB, AC, and the angle BAC again. Find length BC, find the area. Oh, that's like the same thing. Oh, the only difference is that the angle is 120. How do we do cos 120? Because remember, this is like the same question. AB, AC, BAC. AB, AC, angle BAC. Which means it will be the cosine rule again. Yeah? Because AB, AC, and the angle A. Right? So that's the two sides and the included angle. So that will be the cosine rule. Okay? Cosine rule is always two sides and the included angle. But this one is 120. If it is 120, how do we find length BC? Well, we need to work out cos of 120 degrees. How do we find cos of 120 degrees? What idea are we using here?
Is it like 90 and 30?
No. This is the symmetry angles.
Oh, it's like 180 minus that.
Yes, it's 180 minus 60. Right, because it'll be 60 and this is 180 plus 60 and this is 360 minus 60 or pi minus alpha, pi plus alpha, and I erase that, and pi 2 pi minus alpha. So 120, right, essentially 180 minus 60, which means in the symmetry angles it will be this one here. Okay, and cos of that, is it positive or negative?
Negative.
Yes, cos will be negative. Therefore, cos of 120 will be negative cos of 60. Because remember, the number is the same, the sign is different depending on which quadrant it is. Okay, based on the main base angle. So negative cos 60 is negative 1/2, and it's got to work out the rest.
Yeah.
Okay, the rest is the same. So yeah, so that's the simple familiar. So these are very good simple familiar questions because I think in the exam, this is the extent they can ask you for simple familiar. My bet is that trigonometry will be, for tech free, yeah. My bet is that trigonometry will be a lot heavier in the tech active one. Including the probability. So probability and trigonometry will be very difficult in the tech active.
Yeah.
The tech free will have a lot more of these kinds of questions here. Right? Second derivative, deriving twice, and you might need to solve the kinematic questions using polynomials. Might need to use the factor theorem to solve for a cubic equation. If you're unlucky, they can throw that in there. Or the second derivative to find nature of the points and stuff like that. So the second derivative I think will be heavier on the first paper, but on the second paper, a tech active one will be very heavy on the trigonometry and then definitely probability.
Okay.
Okay, because many of the questions in trigonometry you can't work it out without a calculator, and even with a calculator it's still difficult to work it out. And the same with the probability ones. Okay. Now, these kinds of questions are the ones that I wanted to wait until now to go through. This will probably feel a little bit new. Right? It's based on the concept we've gone through before, but it might feel a bit new because of how they phrase it. Okay, the random variable x has the following probability distribution. This is an example of a tech-free probability question that is still difficult. So, what's the probability that x is more than 3 given x is more than 1? Conditional probability, she's got to go through it. Okay, so first that the top would be probability of x more than 3 and x more than 1 over probability x is more than 1. Okay, so I'll give you guys another spiel on the conditional probability again, because you know normally the number line goes from negative infinity to positive infinity, right? So that's a whole domain, right? If they restrict given x is more than 1 means, let's say 1 is here, we are restricting the domain to only be strictly on this side only. It doesn't include anything less than 1, right? And now we find the probability that it is more than 3. So more than 3 is here. More than 3 means it's this section here, right? So it's like saying, okay, what's the area of this part divided by the area of this part? Does it make sense?
Yeah, a little bit.
Yeah, because probability if more than 3, given that is more than 1, means it must be more than 1 and it also must be more than 3. So it's that part there, right? Exclusive.
Okay.
Yeah, because that's the part that that will that will overlap with the part that's more than 1.
Yeah.
Okay, and then what's the total probability? The total probability is this entire section, right? Is this entire thing. So if we were to highlight the red one compared to the total probability, it looks something like that.
Yeah.
You see how the red one is like a smaller section of the total probability.
Yeah.
Right? So that's what it means by conditional probability. They're restricting it to a smaller domain and they take an even smaller domain in that smaller domain.
Yeah.
Right? And then and then you find the probability of that. So that's the intuition, but otherwise you can just use the number line to figure this one out. So if you just figure that one out, I'll just write here 1 and 3, 1 and 3, right? More than 1, more than 3. So the part that overlaps is more than 3. Therefore, this is equivalent to probability x more than 3 over probability x more than 1.
Yeah.
Which is then what we were talking about over here. Right, the area after 3 divided by the area after 1.
Yeah.
Okay, now how do we find probability x more than 3 here?
You just add them up. Like just get 0.1.
Well, it's just this one here, right? Yeah, because more than 3, so it doesn't include 3.
Yeah.
So that would be 0.1, and then probability x more than 1 is?
0.9. Yeah.
Right, it's those ones. So the answer would be 0.5. Right, so that'll be 0.1 over 0.5, which is 1 over 5.
Yeah.
So 0.2.
Yeah.
Okay?
Yeah.
Okay, I'll go to question B as well. Feels a bit different. Probability x more than 1 given x less than equals 3. Probability x is more than 1 given that x is less than or equals to 3. Okay? C and D is a little bit different. So that using the conditional probability rule would be this one, and then intersect with x is less than or equals to 3 over PR of x less than or equals to 3. Right?
Yeah.
Yeah? And then number line. 1, 3, more than 1 and less than but equals to 3. What's the resolved condition?
More than 1.
Just more than 1?
Let's wait, more than 1. What?
Which part has the two lines overlapping?
3, 1. They both do.
But does it overlap here? Both of them?
No.
No. Does it overlap here?
No.
No. So what's the overlapping part?
1 to 3.
1 to 3. Yes, from 1 to 3. Okay, but is it so from 1 to 3? If it's just like an area in between two numbers, you can write 1 less than x less than 3. Is that right?
No.
Why?
It's equals to the last one.
Yes, it equals to the last one, equals to 3. Very good. So then, if you look back at the box here, 1 less than equals x less than 3, what numbers?
1, so 0, oh wait no, 0.2 and just 0.3.
No, it's more than one exclusive. So you're only looking at 2 and 3.
Yeah, that's what I mean. 0.1 plus 0.2.
Oh, so what you meant? Sorry, I heard you 0.2 for some reason.
Oh.
But yes, if you said 0.1 plus 0.3, then yes, that is correct. So that would be equals to 0.4, and then probability x less than equals to 3, which means these 4.
Yeah, so 0.9.
Yeah, 0.9 is 1 minus the other one. Very good. So yeah, so that would be over 0.9, which is just 4 over 9. That's it.
Would it be 2 over 3?
No.
Why not?
Because when you're simplifying fraction, you're not taking square root of it. When you're simplifying fractions, you have to divide top and bottom by the same number.
Oh, wait, yeah.
Okay, so it'll be 4 over 4.5. There'll be 2 over 4.5,
Yeah.
which you don't want. So 4 over 9 is the simplest one. Question C. Okay, let me copy this again. Okay, because you will need to see this again to visualize this. Okay, for question C. We'll crop this. C and D, the mean and the variance. How do we find the mean?
Do the E of X thing.
What's the formula for E of X thing?
I can't remember. Mu.
No, this is mu, yes.
Yeah, that's equal to mu. But that's like.
Do you remember the continuous version?
I know there's like a one where it's like 1 minus P over. I don't know. I can't remember.
Okay. Expected value in the continuous, okay, in the continuous version.
Oh, NP. Where is that one?
No, that's the Bernoulli, that's the binomial distribution. This is a continuous random variable. When you antiderive from left to right of not just the function, because if you antiderive the function, the answer is 1, right? The total area is 1. But in order to get expected value, so if you want to get mu equals to something, you got to times the x into the function.
Oh, yeah, that's right.
Yeah?
Yeah.
So this is in the continuous version. But in the discrete version, it's just this. You're just summing x times the probability of x. All of them. Okay? Or probably x equals to x, this is more like it. So it's just summing x times into the probability and then add all of them together. So this one would be, I'll write the x values in blue. Okay? So there'll be 0 times something, plus 1 times something, plus 2 times something, plus 3 times something, plus 4 times something. Okay? And it's 0 times the probability of 0, so it's just this one here. So 0.3, 0.2, 0.3, 0.1, and then 0.3, and then 0.1.
Yeah.
Okay, actually maybe I'll write the times in using this symbol, easier to see. Okay?
Yeah.
And then you add them all together, because this notation is summation. It's you're summing everything, adding everything together. So you find this product, that will be 0, and then 0.2. Just work it out bit by bit. Don't try to combine too many steps. These decimal operations are a bit tricky. 0.9, 0.4, and then add them together, it will be 0.8, 0.9, that's 1.7. So the expected value is 1.7.
Yeah.
Okay, so yeah, all right, and then the variance. What's the formula for variance?
Isn't it just the EX squared?
Yep.
But then it's just X, so it's...
Is it just EX squared?
Nah, it's the antiderivative thing. Wait, no, it's X squared times the original one, right?
Yes, it's x squared times the original, yes. But var x is not just EX squared. It's EX squared minus the mean squared.
Yeah.
That's why you needed the mean from the previous one. So then EX squared would be, now I just wanted to ask the formula first, but now we're going to calculate the EX squared thing. Okay, so same thing, E of x squared, remember it's just the only difference is you're still summing but instead of times x into it, right, we're multiplying it by x squared.
Yeah.
Okay, so you gotta square every single blue numbers here, 0, 1, 2, 3, 4. So that would be 0 times 0.3, which is 0. I'm just gonna skip through a few things. So 0, actually no, I'll write it. 0 times 0.3 plus 1 still, times 0.2 plus 4, times 0.1 plus 9, times 0.3 plus 16 times 0.1. Okay, so then that would be 0, and then 1 times 0.2 is 0.2, 4 times 0.1 is 0.4, 9 times 0.3 is 2.7, 16 times 0.1 is 1.6, and again, this is tag free, you gotta do everything by hand. So that's 0.6 times, plus 2.7, 1.6 is 4.3, so that would be 4.9. Okay, and then you gotta do EX squared minus mean squared, so that will be 4.9. So they ask for variance, right? Yep, because you can't do square root on a non-tag paper. So 4.9 minus the mean squared, which is 1.7 squared, and this is how they test your decimal number operation. There's no way for you to do these things easy. You just gotta work through it. 17 squared, if you remember what it is, you can work it out. If not, that's fine. Just do 17 times 17. 7, 7, 49, that'll be 1, 1, and then 1, 7, 2, 8, 9. Looks about right. But that will be 2 decimal places, so it's 1.7 times 1.7, so that's 2.89. And then you gotta do decimal subtraction. So see, in the one question, they can test you everything from the recent stuff to all the way to grade 7, 8, 9 stuff.
Yeah.
In the one question. If you can't do these parts, you won't get all the marks.
Yeah.
That's how they differentiate between those who are really good at math and those who are just okay at math. So subtract that would be 8, and that would be 10. Subtract 9 is 1, 0, 2.01. That's a variance. You can't take square root of that, so that's why they don't ask you for standard deviation. They only ask for variance. Okay, so that's a computational question for variance and mean. Alright, so that's why this question is a little bit different.
Yeah.
Alright, we go through a few more. Let's see how many more. Oh, and getting into complex familiar. Okay, so I reckon today we'll probably maybe be able to cover everything. What question are we on? 13, that's 33. Yeah, no, we can't cover everything, but that's all right because the hard ones are really hard, but that's all right. We'll probably cover up to like maybe 27 if we were lucky. Okay, all right, try this. So in this review chapter, don't be fooled by simple familiar questions. They're pretty difficult.
Yeah.
Okay, simple familiar is only simple familiar when you have done all of your revision. Then it's supposed to be simple familiar. It just means that these questions will be considered simple familiar in the exam.
Yeah.
That's why the average mark is like 60%. People can barely do the simple familiar.
Yeah.
Okay, so this one, EX equals 2.34, find the values of A and B. When you see solving for two variables, you think?
Simultaneous.
Simultaneous equations, that's right. When you think simultaneous equations, you need to form two equations, right? So you gotta get equation 1, and then you gotta get equation 2. Right? How do we get the first equation? You use one of the information that they give you. Expected value, again, we did that before. It's just take the value and then you times it by the probability. Take that times that, take that times that, and when you sum all of that, that will be the expected value, 2.34. Okay, so equation 1, use expected value equals to 2.34. So that would be 2.34 is equal to 1 times A plus 2 times 0.3 plus 3 times 0.1. So at this point, you gotta be able to do it fast. And then plus 5B. Alright, simplify. 2.34 equals to 0.9, 1.7, 1.7 plus A plus 5B. Take the 1.7 to the other side, subtract that. That will be 1.64 equals to A plus 5B. You see how it separates like those who are actually good at math and those who are not so good actually. 0.64. Okay? You can do the subtraction on the side. You see the answer the same. So that will be equation 1. Equation 2, you need to use another idea. What ideas do we use here? This is a probability distribution.
So maybe 1 equals something?
Yes. Use 1 equals something. 1 equals what?
Just 0.6 AB.
Not 0.6 AB, you're close.
Plus A
Plus
B.
A plus B, yes. Alright, so 1 equals to total probability. Alright, so 1 equals to 0.6, which is the sum of these three, plus A plus B. So A plus B would be 0.4 equals to A plus B. This is equation 2. How do we solve this?
Subtraction.
Subtraction. 1 subtract 2. 0.64 subtract 0.4 is 0.24 equals to A subtract A is gone. That would be 4B. So B would be 0. What?
4 and 1. Oh, I don't know.
Okay.
I have to draw it out. I can't do that in my head.
Now, this is when I pause here because I think I need to review you guys on place values. 0.24 is 24 hundredths with the TH, right? If you are doing 0.24 divided by 4, it's 24 hundredths divided by 4, which is 6 hundredths, right? What is 6 hundredths? 0.06.
Oh, yeah.
Yeah, so you can convert it to the place value because it's fully divisible. You don't actually need to work through it by hand. So fully divisible, so you can think of it in terms of place value. And then once you convert it, once you do the division, you convert the unit name back into what it means as a decimal number.
Yeah.
Okay? So just remember 1 would just be 1, right? 110 is 10, and then 1/10 with the TH is 0.1. Okay, so the 100 and stuff is easy, but 1/100th, right? 100th would be 0.01.
Yeah.
Why is that the case? Well, it just means 1 times 100, which is that. Right? Because when you actually do division, it will be 0.01 when you divide 1 by 100.
Yeah.
Okay, so that's why 0.24 is 24 hundredths. So you actually look at the last digit here. So it'll be 24 hundredths. Divided by 4 is 6 hundredths, which is 0.06. Alright, so the answer is 0.06. If you know this, it will make your working a lot faster than having to do long division. You can, another way of thinking about this, okay, I'll give you another version. When you divide by 4, so 0.24 divided by 4 is the same as do 24 divided by 4 and then put back 2 decimal places. Okay, because there are 2 decimal places, right? So you put it back. Okay, you can think of it that way. So another example is, let's say 0.030, right, divided by 5. Okay, so 0.03 divided by 5 is 0.0. You want to make it into a number that you can divide by 5. So how many decimal digits? 1, 2, 3. 30 divided by 5 is 6. Put back 3 decimal places. 0.006.
Yeah.
Okay, so if you're comfortable, you can do that. So whole number division and then put back the decimal places.
Yeah.
That would be the same as using the place value thing. Right? Either way. Okay, so that's B, and therefore A. So we'll sub this one back into equation 1. 0.4 equals to A plus 0.06. So A would be do the subtraction. 0.34 equals A. Okay, so that's your A and B. That's the 2 probabilities.
Yeah.
Okay, so yeah, so this one, the algebra is a little bit strange. Right, it's a little bit different. Okay, let's see. These simple familiar questions, definitely not easy. Oh well, good practice. A biased coin is tossed 3 times. After this one, I'll pause the I'll end the first half of the recording, and then I'll continue the other questions in the second half. So a biased coin is tossed 3 times. On each toss, the probability of a head is P. Find in terms of P the probability that 3 tosses show tails. Okay. Find in terms of P 3 tosses. All 3 tosses show tails. Right? Because it's only tossed 3 times. So then the number of trials is 3. When you see this probability on each toss, it has a probability, and then how many times it is tossed, so that's the P value. Right? When you see that, you think binomial distribution. Right? This is a binomial distribution question where what's the probability all 3 tosses show tails? What does that mean? It means probability success equals to 0.
0.
Yeah? So
oh wait, yeah, it makes sense because probability says
yeah, this is success.
Yeah.
Right? 3 tails means the probability means no successes. Okay? Which is the same as probability of x equals to 0. And then you sub it in. Right? So that would be 3, 0, and then p power 0, p minus 1 power 3.
Yeah.
Yeah? It's just a formula of binomial distribution.
Yeah.
How many times you get successes? 0. How many times you fail? All 3 times. And this is the permutation, 3C0. What's 3C0? Always 1. Okay? So remember, A0 is always the same as AA, which is always, let's say, C0, and then CC, that would be always 1. Okay? No, that should be equal, equals to that. Okay? The reason is, remember the pyramid, it will always start with 1 and ends with 1. Right?
Yeah.
And the start number is always something. For example, this row would be 2, 3, 4, so that'll be 4, 0, and the last one is 4, 4. So think of it this way: if you have all fails, there's only one way. Fail, 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 fail. There's no other option. Right? If it's all success, there's only one way. Success, success, success. There's no other option. Right? But when you have some successes and some failures, that's when you can swap the locations around. So yeah, so P0 is 1, P minus 1 power 3 is just P minus 1 to the power 3. Alright, so that was just P minus 1 to the power 3 is the final answer.
Okay.
Okay? And then B, if the probability of 3 tails is equal to 8 times the probability of 3 heads, find the values of P. Not too bad, you can work it out. Probability of 3 tails, again, what we just found that, so P minus 1 equals power 3 is equal to 8 times the probability of 3 heads. What's the probability of 3 heads? Oh, 3 tosses. Head, head, head.
Would it be the same?
Almost the same. Because 3 successes.
Yeah.
Right? If you fail 3 times, and that's like every single time you throw you fail, that's the only option. If you succeed 3 times, that's the only option.
Yeah.
Right? Because if you were to even use a formula, it would be 3, 3, P power 3, and P minus 1 power 0. Right? Power 0 equals to 1, 3, 3 equals to 1. So the answer is just P power 3.
Oh, okay.
Okay? So using the formula, the answer is still the same. But yeah, so at this point, how do we solve cubic then? Do you want to expand this?
Probably not.
Probably not. So how do we solve this?
Take the Q away on either side. I don't know if you can do that, but
It's very close. So this is what I prefer. You see, this is a factor, right?
yeah.
Right now, if you take cube root, it's a bit harder to work with. But if you convert this one, you know this 8 is 2 cube. Convert that one to 2 cube times P cube. What happens here?
Now you can just cancel them all out.
Now you can just cancel all out. Yes, because you get this, right? So something cube equals to something cube. That means the 2 things must be the same. So therefore, P minus 1 is the same as 2P. Right? Move the 2P over there. Move the 1 over there. You should get, hang on. 3 tails is equals to 8 times the probability of 3 heads. Eight times. Yeah, it looks about right. Hang on, 2 times. P. Oh, sorry, not P minus 1. What did I write? P minus 1. 1 minus P. Yeah, sorry, it's the total probability minus the probability of success, not P minus 1. My bad. That should be 1 minus P. And so this is 1 minus P, and this is 1 minus P. Okay?
Yeah.
Because if success is 0.4, then failure is 0.6, so it's 1 minus the success probability.
Yeah.
Okay, so yeah, so now that makes sense. So 1 equals to 3P, 1 over 3 equals to P. Alright, that's a probability. So it's a biased coin where every 3 times that it is thrown, only one head is expected to show. 2 other times will be tails.
Okay.
Okay, so yeah, so that's example 15. Okay, let's take a short break in class and I'll pause the first recording here.